So, you want to save the world with clean energy? Make money doing it? Confused about the economic and technical realities of residential and commercial solar, batteries, heat pumps, EVs? Want the real-world scoop on new energy technologies, not manufacturer hype? Then tune in to the Weekly Energy Show, hosted by Barry Cinnamon. Insights from Barry's 40-plus years in the solar and energy industry will help you understand the future ways we'll generate and consume energy. And now, here's Barry.
Welcome to this week's Energy Show. Now, heat pumps are a hot topic right now. The technology keeps getting better. The energy prices are going up steadily, so people are looking for ways to save money. And there are these things called REACH codes in certain parts of the country, a lot of them right here in Silicon Valley, that require putting in a heat pump whenever an old air conditioner dies. So it's a hot topic, literally. Then there's big questions, and they're new, and it's always expensive to retrofit things. So we're going to kind of talk a little bit about how heat pumps really would fit into a typical residential home. Now, it's almost always cheaper to operate a heat pump than an old natural gas furnace and old air conditioning units. And the table that we have up here is some back of the envelope modeling that we did. Now, the thing you have to remember if you're putting in a heat pump, which is powered by electricity, is you're not going to use natural gas anymore for heating, maybe still for cooking, but not for heating. Ideally, you put a heat pump water heater in so you don't need it for hot water either. No more natural gas, but you're going to be using more electricity. So when you're really looking at the economics between a heat pump or an old gas furnace, or even if you want to retrofit fix your old furnace, you have to kind of look at what the current electric rates are and the current natural gas prices are. So we've got that kind of summarized in this table above. And then you have to compare the efficiencies of that old natural gas furnace and that old air conditioner to a high efficiency new heat pump. And what's interesting, and these numbers here are for the California area, the annual heating and cooling costs with a heat pump are a few $100s cheaper per year. Not outrageously cheaper, but a few $100s cheaper. Nationwide, that really changes depending on the ratio of natural gas to electricity prices. So when you have expensive natural gas and inexpensive electricity, the heat pump starts making a lot more sense. It also depends on the climate. If you're in a warmer climate, you don't need as much heating, you're getting better savings with the heat pump. And then the column on the right is the one I like the most. If you have solar, which is effectively a much lower electricity rate, you're going to get much better economics with a heat pump. So when I go to customer heat pump installations, and we've got their salespeople out there, things like that, I get the sense that homeowners really don't understand what goes on during a heat pump installation. And there's a lot of misinformation out there about system operating costs. So this week, we're going to be talking about the practical aspects of retrofitting a heat pump system in your home. So mostly for retrofits. So when your air conditioner dies or your gas furnace breaks down, you'll know what to do. And my guest on this week's show is Dana Fischer. Dana is the Director of Regulatory Strategy for Mitsubishi Electric in the U.S. Heating and Air Conditioning Division. That means he knows about incentives, about homeowner energy programs, about these things called REACH codes, and all the public policies that our friendly local and federal governments are implementing to make it more cost effective to put in a heat pump. Plus, he's based in Maine, so he knows a thing or two about how well heat pumps work in cold weather. So welcome to the show, Dana.
Hey, Barry. Geez, thanks so much for having me on.
We're big fans of Mitsubishi. That's the only equipment we install. Tell our viewers a little bit more about Mitsubishi's heat pump business.
Well, Mitsubishi, of course, as a company overall, has been around for more than 100 years. And in the United States, we've been selling mini splits since the 80s. So we've had one of the longest presences in the United States of any manufacturer. And you can still find systems installed in the early 90s that continue to operate.
I recently saw a chart that showed all these different heat pump brands, but there's only a few major manufacturers. It kind of reminds me of the worldwide automobile manufacturing business. So how does Mitsubishi fit in among these major manufacturers, even though there's different brands?
Well, of course, a lot of the large companies that you're referring to in that chart are global companies, and Mitsubishi manufactures products at factories all over the world. And we have a U.S. entity that coordinates the manufacturing for the U.S. marketplace with select factories, and we tailor the product specifically for the market demand in the United States. There has been a fair amount of consolidation and relationships built between companies that have resulted in this sort of reduction in the number of key players over the past few years. I think part of that is due to the fact that the United States really, even though there's some line drawn between the invention of variable speed inverters and systems in the United States to that technology basically migrating to Asia and becoming dominant in almost the rest of the world, while the US has continued to use single and two-speed compressors. There's just a really fascinating, interesting history about how that's happened and the trends. And so now, while most of Europe is using heat pumps and 90% of homes in Asia use heat pumps to heat and cool their homes, the US is just now really starting to catch a fire with the technology. And so all of the traditional HVAC manufacturers are trying to coordinate with somebody, any company that's been using inverter controlled variable speed compressors for a long time to try and make sure they're filling out their portfolio of products for the US market.
And the first time I really came across the individual mini split heat pumps when I was traveling in Asia, basically I've only seen mini split systems. Whereas here in the US, most of the systems are ducted. Why is that, and how will that possibly change?
It is a very interesting thing. I think it's even, you can dial down that a little bit further. When I visited Japan, what I noticed is that not only are there mini splits everywhere, but they're all single splits. In most of Asia, they don't use multi-zone systems on residential structures at all. They just might have 2 or 3 or 4 units, depending on the size of the structure. And what's more is that, and I know we'll get to conversations around sizing, people just inherently know what size they need for whatever application. They just go to the equivalent of Best Buy and they look up on the wall. They're like, hey, I like that model and that price. I want a 12,000 unit because that's the size room I've got. And off they go, and it gets installed the next day by the Geek Squad. So, the whole marketplace is quite different in the rest of the world and how people install the systems, size the systems, purchase the systems. And I think that we'll eventually get there in the US, but there's still a lot of trepidation and lack of familiarity with how these systems work and where they belong. And so, we're kind of working through a lot of the heartburn associated with the industry kind of figuring it out. And that gets to ductwork. I mean, I think initially when people see ducted systems, they're like, oh, I don't see that on my wall. And they're sort of used to having that central system. But at the same time, I don't think it's very easy to find anybody who would claim that their ducted system provides nice, even comfort throughout their entire home. So, and of course, ducted systems, there's a whole lot of friction in the ductwork and dust and debris and all the rest of it. So there are health issues associated with ductwork. And there are penalties on energy associated with ductwork because you have to use bigger blowers. So there's a lot of reasons to go ductless, but you got to go where consumer preference is, and if they want to retrofit from an existing furnace or whatever air blown system, all the manufacturers, including Mitsubishi, have the equivalent of central systems that use the variable speed inverter technology in the outdoor unit, and can deliver complete comfort regardless whatever is existing.
We're seeing most of our customers are putting in, they have existing ductwork. We make sure the ductwork is good. A lot of times we'll replace part or all of the ductwork that's accessible. And then we just put in a ducted system. But, a good percentage are putting in mini splits, or they've added onto the house and they want mini splits working in certain rooms. So, it's becoming pretty common. All right. Well, let's talk a little bit about technology. You mentioned variable speed compressors. What does that mean, and what's the advantage of a variable speed compressor?
Well, it certainly depends on what part of the country you're in as to what kind of temperatures differences you might find between indoor and outdoors. And, that varies, from time to time. And so if you have an inverter that can throttle down to a middle speed or a low speed, and in maybe 20 different speeds in order to match what the actual heat load of the house is, you can achieve some pretty incredible efficiencies. And so the system's unlike, a furnace where it'll turn on, satisfies the temperature, shuts off, or even single stage AC, it turns on, cools down the house, shuts off, and waits for the temperature to rise up. Variable speed technology will run consistently for a long period, like ideally all the time, but it just sort of whispers along and delivers the amount of cooling or heating that's required in order to meet the load. So the temperature is very consistent, the comfort's better, and by operating at sort of like lower or medium speeds, you're taking advantage of the relatively large size of the coils compared to the refrigerant flow, and it provides a higher level of efficiency, for the system, and can be beneficial for moisture removal. So really, it's an efficiency difference that can be achieved through variable speed systems.
It's kind of like driving a car, right? If it, one of my daughters basically saw that pedal on the floor, and it was either all the way on or all the way off. It resulted in a very uncomfortable ride, and it took a little while, but not very efficient. Whereas, you can gradually accelerate, gradually slow down. It's better. So,
yeah, cruise control is a good analogy for that.
Yeah. Don't even get me started. I'll get in more family trouble than I deserve. Well, I started to see the word inverter popping up with heat pumps, and I probably put on like 100,000 inverters or more in my career in the solar business, and they're all inverters to convert the solar DC into AC for the house. But why is an inverter involved in a heat pump?
So the compressors, the inverter-driven compressors, are all DC motors, but they're really kind of like, it's almost like three-phase high voltage DC. And so it doesn't matter whether you're talking about coming from 12-volt DC, in weird solar heat pumps that are out there. I mean, most of the systems are, especially in the US or Europe, 240, or 210, 220, whatever it takes, right? 220, 221 isn't the line. And so it takes that power in, cleans it up on the power board, converts it into basically like a three-phase high voltage DC to power the compressor. And that's really one of the other key parts of the efficiency of the system. The motors, because of the use of the inverter technology and the high voltage conversion, just are incredibly efficient. And that's where you get your rare earth metals used in the magnets for the compressors, and really sophisticated technology with flash injection to allow for performance even at really stupid cold temperatures like negative 20 degrees Fahrenheit.
Like you get in Maine every winter.
It happens. I mean, this was a very cold winter, consistently cold, seasonally colder than usual. We had snow on the ground from early December all the way into March, which is unusual. Usually it sort of comes in spits over the course of November and December, but never really parks in your yard until January for the long ride. But we really had a traditional winter that you might expect from 20 years ago. And my house, it's not a big house. It's an old house, 1820s. But I've made some improvements to the shell, but I heat the entire thing through the entire winter with two 12,000 BTU units, one in my basement and one on the first floor. And, I'm still married, so perfectly comfortable, and I haven't used backup heat in a very long time. So just, and it does. A couple of years ago, we did have a weekend where it hit ambient of negative 20 across Maine. With incredible wind. I mean, the wind chill factor was negative 40 to negative 50 in parts of the state. And, we know Mitsubishi contractors from across the state that have thousands of clients. They get no phone calls. I mean, it's like, there are more calls for conventional furnaces and boilers failing during extreme weather than heat pumps. That's for sure.
That's interesting. All right. The last three-letter acronym that I see is VRF, which stands for Variable Refrigerant Flow. What does that mean?
Well, so there's sort of there's an industry aspect to this, and then there's sort of the reality. I mean, all the variable speed systems, of course, have variable refrigerant flow, right? That's the whole idea behind it. But whenever you see somebody refer to VRF or variable refrigerant flow, they're referring to systems that are greater than 65,000 BTUs, or at least for us, that means a three-phase system that's above 65,000 BTUs. That's like a multi-zone system. That might be in a commercial application, large multifamily, that sort of thing. So that's what VRF is, and they are also fantastic for delivering comfort, in school buildings. Just great to make classrooms comfortable so that students can really focus on the chalkboard.
So many parts of the country, we kind of touched on this a little bit. They have humid climates. Not here in the Bay Area. It's pretty dry. Down in the Southwest, it's very dry. How do heat pumps manage the humidity control when you've got a lot of humidity?
That's a mixed bag. That's a tough question because humidity removal really depends on the temperature of the coil, relative to the room temperature and the rate of the airflow of the fan over it. And so in some regards, heat pumps can remove some moisture, but it's not like you can control the moisture particularly well without having a second coil. And so if somebody has a real high moisture content in their house for one reason or another, depending on their usage patterns or where the house is located, like next to the bay or whatever, even if they put in mini splits, or any other AC system, there may be a requirement to put in dehumidification to really control that temperature. I know that we're working on products that would be able to, manage both a temperature and a humidity set point with some technology. We're really excited to have those kinds of products coming down the pipeline. But you definitely get some humidity relief from the use of AC. During the summer months, but being able to dial in a particular percentage of humidity is beyond the capabilities of most systems at this point.
It means a lot in parts of the country that are really, really humid, but the regular air conditioner might not do any better of a job than a heat pump. So, okay.
Absolutely.
There's this system sizing technique called manual J that's recommended by a lot of people to figure out exactly what size HVAC system to put in, where you're looking at the building shell, the insulation from the sun, temperature settings and everything like that. And we have some jurisdictions here in Silicon Valley where they're saying, well, we need to see a manual J calculation for the home that you're installing this heat pump in, even though it's just a straight retrofit of taking out a furnace, taking out an old AC condensing unit and putting in a heat pump. What is manual J, and what's your opinion on how accurate that is as opposed to maybe other ways of determining how big a heat pump to put in for a retrofit customer?
Great question. So ACA Manual J is a sizing model tool methodology that's been around for decades. And, there are plenty of software platforms now that can perform manual J calculations to determine load. But manual J, for the longest period of time, was, sort of the kind of thing you'd sharpen your pencil and work out on a worksheet. And it's really, there's no magic to it. It's a bunch of fudge factors that some smart dude came up with decades ago to try and come up with some uniform way to size systems, because prior to that, it was just ridiculous. Who knows how they were actually sizing systems? But as is the case with engineers, and I'm probably going to get some phone calls on this, they all intend to add a little bit of a fudge factor to make sure that they're going to be covered and that, they're going to have best outcomes. Well, so manual J has a little bit of fudge factor in it, and then contractors tend to be a little bit generous in how they set it. And then, the equipment manufacturers tend to be a little generous to make sure nobody's calling them out on it. And you end up most of the time when somebody conducts a manual J with something that's dramatically oversized, even when you're relatively careful. There was a study that I saw a presentation on just a couple of months ago at the ACEEE Hot Air, Hot Water Forum in Phoenix, where they did a very careful study of, conducting, very careful manual J calculations, doing another energy model, comparing it to utility records over the course of years, and then also putting in all of the measurement gear to gauge what the actual load of the building was. And they found manual J on these on all the homes that participated to be oversized by between 70 and 200%.
Wow. Wow.
So it's like, and the thing is that manual J has been around forever, so it's embedded in building code. And so it's honestly a requirement. If somebody's going to build a new structure or whatever else, they're in most jurisdictions required to conduct a manual J. I don't know if it's really adhered to everywhere, but that's kind of the idea. And so my guidance for folks that are doing manual Js or looking at manual Js is don't add any fudge factor, first of all. And secondly, really look at what the current consumption of fuels are. And there's a very direct correlation between annual usage of fuels and what the actual peak load is. And you can research and find out what that is. But at the very least, do that calculation and to compare so that you're not just coming out with a manual J and you have no idea if it has any basis in reality or not. But jurisdiction requires a manual J, fine, do the manual J, but like go low. It's so common for people to just dramatically oversize them. And it's been the case for a very long time. There was a study by ACEEE in 2008 referencing tens of thousands of California homes. And they found that on average, AC systems installed in California were 50 to 70% oversized. So, you can't just look at what your existing system is at 3 tons and say, well, I need a 3-ton system, because there's a very good chance that system itself was dramatically oversized.
Yeah. For heating purposes, we basically just record, because we're doing the solar analysis anyway, we're pulling their utility bills. We've got not only that 15-minute interval data for electricity, but we've also got 12 months of therms data. So we can figure out what the summer usage is, which we can interpolate into what the hot water heating is, and the rest of it is all heating natural gas for space heating. And we can come up with an accurate estimate. And it pretty much inevitably comes out that if we put in an air conditioning, a unit that has the same air conditioning capacity as the existing unit, we'll have plenty of heat. And really, the only issue is, do we want to maybe even cut that back? But it's a non-issue, I think, for retrofits. And I can understand why you have to do some kind of modeling for new construction. But for retrofits, in 5 minutes, we can do a model that's much more accurate based on existing consumption.
Well, and I know there's this sort of like cost battle between, and you talked about at the top of the hour, the cost battle between what the electrical utility costs or the gas utility costs are. And I mean, like, that doesn't really take into account and of course, I live in Maine. I'm a long ways from this, but my understanding is that something like 40% of the smog is caused by residential gas use, primarily furnaces and water heaters. And so, if you're like, hey, wouldn't it be great if we had some better air quality around here? You can make a really big difference by switching over and being all electric. And I know that in California, there's different, programs, whether it's Tech Clean or, the Bay Area's objectives around, with the gas district, with the air district trying to reduce the usage. Take that step. Like, look at what it would take to go without gas. Even eliminating your gas stove and looking at like an induction stove or something along those lines, because it's the future. It would be great to have a reduction in smog and better breathing air all around the Bay. And what's more is that, like, as much as you could look at the cost per therm reduction to your comparison to electricity, it's that monthly cost of having the gas running. So, like, if you're able to go all off, that's where you really get some payback. Because if you continue to use 1 or 2 gas appliances and still have to pay that connection fee every month, that really digs into your cost effectiveness.
Yeah. No, that's absolutely the case. There's the Bay Area Air Quality Management District that's right, pushing these crazy acronym, pushing all these conversions, and it's for all the right reasons. And it made a lot of sense when the IRA was still active, where you had some good policies. But we're getting pushback, obviously, from some retired people or people that are on lower incomes that don't want to spend the extra money. But they're never really realistically looking at what it's really going to cost. Even if you were to put a regular air conditioner back in an old furnace, it's still expensive. And with the incentives that you get, a few $1,000s for HVAC, but there's some cities in our area that you have a $3,000 or $4,000 rebate from the city for heat pump water heater, and I expect that those are going to come back into activity for HVAC. It really does make sense, and you're done. Your house is going to operate less expensively, without a doubt, especially if you have solar, and you're going to have cleaner air in the house and outside the house,
and quieter, and more comfortable and consistent throughout the space. I mean, there's a lot of lifestyle benefits that come with it, we all justify a great many luxuries in our lives. And, if you just look at the house and the core things that make you comfortable and make life more enjoyable, having a good quality HVAC system, good control of humidity and indoor air quality, it's fantastic.
Yeah, it makes a big sense. And, when I put in a Mitsubishi system in my house back in 2019, I mean, turned the thing on and it was ducted in 2 zones. We couldn't even hear it. Asked the contractor, is it really on? And it's just worked flawlessly since then.
Yeah, no, it's remarkable how quiet, and not just the indoor units, but the outdoor units. I mean, it can be running full tilt outside in the middle of the winter, and you can stand right next to it and just have a regular conversation. It's totally quiet.
Yeah, and it's also very, very interesting that in the winter, it might be for us 35, 40 degrees is really cold, but you stand in front of that thing and it's even colder. It's just a cold patch of air on the side of my house. Well, let's shift gears a little bit and talk about policies. You've done a lot of work on, it's basically in your title, on the regulatory policies related to Mitsubishi products and heat pumps. Tell us a little bit how that's evolved. And I look at it from a relative newcomer, from the tremendous successes we had in the solar industry, from the tax credits, and then the awkwardness, and I'm using that word loosely, of the rebate programs from some of the well-intentioned bureaucracies. Boy, tax credits are way, way better. Talk to us a little bit about what your observation is for those incentives that are really going to continue to move the needle on getting people to convert.
Yeah, before I came to Mitsubishi, coming up on 9 years ago, I was at Efficiency Maine and helped stand up programs for rebates and financing for weatherization, conventional heating systems, and heat pumps. And so I'm really I have done a lot of deep thinking about, program operation and setting up things that are really helpful to people and facilitate installations. And it's difficult. It's both a science and an art to run a good program. There are a couple of cardinal rules that must be adhered to that people have a hard time getting their heads wrapped around. One of which is that the program has to be very simple. You can't have a lot of complicated things. As much as people like to get big rebate dollars to try and get their eyebrows to rise up, it really actually is detrimental because it ends up escalating the price across the marketplace. And it also, for the administrators of the program, because if they give out big dollar amounts, it makes them sort of feel as though they have to have greater control over every aspect of the installation. And so then they start requiring 27 glossy photos and
the circles and arrows on the back of each one.
Yes, every single last one of them. And before you know it, it takes them weeks to process the rebates. The contractors end up being owed, tens or hundreds of thousands of dollars and back, waiting for the rebates to come through if they're trying to do the work. And and then if you get rejections, there's just all kinds of sour grapes because everybody's missing out on a whole lot of cash. So it just becomes a situation where the contractors dread being part of the program. Consumers are, they're in a worse position because they don't want to miss out on a free rebate or something like that. But the process is so much work that they're like, well, I'll put it off till next week. They never actually end up doing it. So in a lot of ways, these well-intended programs end up dragging the market and creating more friction than help. And so to your point, tax credits, where it's sort of like, I bought the system, it's a qualifying system, I get a tax credit, is great. the problem with tax credits, of course, is you've got to have the money entirely up front, and you've got to wait a long time, or wait a long time to get the money, which is kind of a bummer. So having a really simple rebate program or a midstream rebate program where the discount is delivered at the distributor, so that the contractor doesn't see that cost and passes that on presumably to the consumer, that can be pretty effective as well. But it's also, and this gets to some of the meat and potatoes in California, it's incredibly important that there's a commitment by policymakers to fund the program sufficiently to keep them operating long term. When you turn the lights on and turn the lights off, what happens is that consumers wait for the lights to turn on before they call anybody. And the contractors learn very quickly that when the light turns off and there's no rebates available, the phones stop ringing. So they're not going to hire people. They're not going to buy new trucks. They're just going to live through boom times and survive through bust times. So you don't actually grow the marketplace. But if you have consistent rebates that are modest, that imply good standards for development and have quick turnaround and payment, then the program actually builds awareness with consumers, builds confidence in the reliability of the program, and the increased cash flow really injects funds into the marketplace so that they can build their businesses and grow their staffing. So it's really, that's sort of the key, is having a modest, simple program with fast payout and have consistent funding. And when I'm talking about consistent funding, I mean, it's grown in New England over years, but just to put it in the context of the size of course, California is a huge state relative to most of the states around the country. But right now, Massachusetts, New York, Maine, Vermont are all investing in heat pump installations at a rate, an annual rate that would be equivalent to California spending between $1 and $2 billion a year on heat pump incentives. And that's the kind of commitment that's really required at the California state level, regardless of the funding source. Probably be appropriate to come through carbon markets or utilities of one form or another, not just sort of general fund stuff. But that's the kind of commitment that's required long term in order to achieve goals like 6 million heat pumps by 2030.
And what I would really love to see is some kind of federal tax credit. Obviously, it's not going to happen for the next few years, but a federal tax credit to help people convert from an existing air conditioner to a heat pump, which is going to do both.
Yeah, and the 25C tax credit was around for just 2 or 3 years, and that was helpful. But it was actually, and we were all really in the industry hopeful that it would take off and pick up faster than it did. It was actually kind of surprising that there wasn't more uptake. Of course, that the tax bill last year, the reconciliation bill, kind of struck that or sunsetted at the end of this year. I think there is hope for that to return in one form or another. I think that would be great policy to have that happen, and maybe even streamline the criteria. It would be even better if they converted it into a refundable tax credit. So even if you didn't have tax liability, you'd be able to receive funding for that, because that was kind of a limitation. People that didn't have tax liability were really unable to receive that $2,000. So if you were, on Social Security, you were out of luck. If you were lower income, that wasn't going to be something for you. And of course, I think the policymakers in Washington felt that the funds that they allocated to the HERA program, for rebates that were allocated to the states would kind of take care of that and help lower income communities. But again, like I cited, they just made the program criteria and guidance so complicated that nobody could get off of the ground. The states couldn't figure it out. They didn't have any guidance, and then the administration changed, and the whole apple cart got upset. So, it's an art and it's a science.
Yeah, and hopefully it comes back in a way that's very simple, as you point out, and it makes sense for people with without the tax appetite. But fingers crossed, maybe something in 2029. Let's dive into the realities of actually getting a heat pump. How can a homeowner find a contractor who knows heat pumps, not just one that is going to get in there and say, oh yeah, heat pumps are expensive. I'll just put in a new furnace for you.
Well, you guys are really pretty fortunate for some of the work that's been done at the state level. Of course, Mitsubishi has a contractor network in every state, including California. And so, and I think this is true of most manufacturers. They have some sort of list of contractors. You could certainly go to our MitsubishiComfort.com website and put in your zip code, and you'd come up with a list of contractors that install Mitsubishi equipment and have manufacturer training and are rated as, diamond contractors or, preferred or elite diamond contractors. But you also have a state resource through the Switches On website, which really has a great tool for finding contractors in your area that install heat pumps. And so I'd encourage people to check out that website. And if you're looking for Mitsubishi equipment, absolutely come to Mitsubishi Comfort and look for diamond contractors by zip code. We are constantly working with our distributors and contractors to make sure that they have the materials and the training that they need to deliver best results every time.
Yeah, no, the Mitsubishi training through the distributors that we're working with, it's been absolutely terrific. I personally even, went to the training twice over the last 6 months. So, and I have almost all of our crew going there. It's pretty good. Well, let's say you're a homeowner and you got a few proposals from different contractors putting in equipment. What advice do you have for homeowners to evaluate those proposals?
Well, I think one of the things that we hear from consumers is that, they go out to get 3 or, bids or sometimes more than that, and they'll come out with 4 or 3, entirely different proposals for equipment, entirely different price points for the equipment. And I think that the old sage advice about, find the contractor that fits your personality and what you're looking for really means something. If you have a personal connection to one of the contractors, Paulie, you've got a little bit on that. But you want to find contractors that are going to stand behind the product and the installation, and and have references and pictures of installations that look really good. Like standard craftsmanship counts, making sure that systems are mounted, level, and that the line sets are appropriately protected and run in a way that's attractive. I mean, you're going to be living with this thing for a very long time. And I think that's really, one of the arguments to go with a good quality system is that, it's going to be living in your house with you for a long time. If everybody was just interested in outcomes that would be cheapest, we'd all have a bunch of PTACs hanging out of our house. But nobody likes going to a hotel room with a PTAC because they're lousy and noisy and inaccurate in their temperature and everything. So, you don't want that outcome. You want to find somebody that you can trust to do a good installation, will be there to help you service it if you ever need service or cleaning for the system, and get multiple quotes for sure. And word of mouth is powerful because people that have good experiences will share that. And if somebody had a good experience, you're likely to get a good experience too.
That's good. All right. Well, now you've got the system. What kind of annual maintenance or regular maintenance is required for a heat pump system? And how does that vary from, say, a ducted system to a mini split system?
Well, I mean, like when you introduce ducts, it really, as there's a great deal of variability in the quality of the duct system and the age of the duct system. If you're doing a major retrofit of your system, it's a great time to get a thorough cleaning of your ductwork. One of the downsides of ductwork is it collects all kinds of dust and debris and tractor parts and pollen and whatever. So it's good to get that cleaned out to help ensure good indoor air quality. And of course, replacing filters is critical to that as well. With both ducted and ductless systems, you can accumulate dust and debris and whatever else on the coils on the indoor unit and also on the outdoor unit from, in the outdoor unit, it's spiders and spider webs and wasps and grass clippings and soccer balls. And so you need to make sure you're removing all those things, or looking at the unit to make sure it looks somewhat clean, as you enter, each season, whether it's heating or cooling. And over time, if you really should get the unit cleaned, it may not need to be cleaned every year. It may be every other year or every third year, depending on your house and the folks and the number of cats you have. But you'll kind of get a sense of that. I'd recommend just kind of keeping an eye on the dirt and debris on the systems. And if you ever have a circumstance where you feel like it's not delivering the same performance that you used to, probably cleaning is the first step. And then if you don't have any improvement in that, then maybe you need, a little bit more of an investigation to make sure that, your refrigerant is up to par, and fully charged and that sort of thing. But for the most part, I think one of the things that's great about heat pumps is that if you have a good quality installation where they're taking time to ensure good commissioning of the refrigerant lines and no leaks, they can run for a very long time with very little attention.
Yeah. Basically, just cleaning the filters is about it.
Yeah.
And if you pick the right contractor, the contractor is also going to be responsible to help you make sure it's cleaned on a regular basis if needed.
That's right. Yeah.
Great.
That's why you want to get somebody you like and trust, because you're going to see them again. Hopefully.
Yeah. How did you get into the HVAC business?
It's been a long, strange trip for me. I mean, my degree is actually in philosophy. But I was a microbrewer in the 90s, and I was in the semiconductor industry briefly, and then I was in municipal finance for a period of time. And while I was in municipal finance, I had a friend from when I was working in semi, and we kind of worked on solar thermal pumping stations, and we probably made like 500 of them, and were shipped all over the country. And along came heat pump water heaters, and really kind of, we could see that this was not going to be a long-lasting endeavor. And at that point in time, Efficiency Maine, was plucked away from the Public Utility Commission in Maine, and they were looking for somebody to set up PACE programs. I know you guys know a little bit about PACE in California. We had a slightly different version in Maine. So I was the guy that was going around to, the municipalities to get them to create and pass ordinances to allow for PACE loans to their residents. And that financing, that PACE financing, continues to circulate in the state of Maine and provide funding for heat pumps. We never got off into weird uses on landscaping or that sort of thing that were kind of problematic in parts of California. And so, I was working on rebates and everything for heat pumps. And and we were doing really well. And at one point in time, one of the guys that I knew from the heat pump industry that was kind of, and when I had a really tough heat pump question, I'd call up Roger and get some insight. He called me up one day and said, "Hey, Dana, I got promoted. I'm looking for somebody, to take up a role, doing sales work in Maine and New Hampshire. Do you have any suggestions on who I might call?" And so I took that opportunity and jumped the fence. And, I really enjoyed being in sales for heat pumps with Mitsubishi and talking to contractors and working through pathways to grow their businesses and be more robust and help consumers. But eventually people at Mitsubishi figured out that I had this weird background in municipal and rebate program design. So I got moved to the utility team and then eventually into regulatory. So that's where I'm sitting now, and it's a lot of fun. It's very challenging. I'm going down to DC next week, but I travel all over the country, and I visit California with some frequency. I'm going to be out there on June 9th and 10th for the California Heat Pump Partnership meeting in San Francisco, and the EPRI heat pump event in Sacramento, and doing everything I can to talk up heat pump policy and make sure folks are moving towards best policies and best practices. So
it's just an integral part of building electrification. When you have solar, when you have heat pumps, when you have EVs, you just don't need to burn any of that polluting fossil fuel at all. And it is definitely the wave of the future.
Yeah, Barry, you and I are on the same page, 100%. It's just better, and it's where we need to go, and it's not painful. Everybody's going to like the outcomes. There's nothing better than enjoying a sunny day and knowing it's helping your house, and you're just feeling good.
Yeah, terrific. All right, well, that's all the time we have on this week's Energy Show. Thanks, Dana, for joining us, and thanks to all of our listeners for tuning in. If you have any questions or if you missed any parts of this show, you can always go to our website at energyshow.biz and listen to the podcasts.
Thanks for tuning in to this week's Energy Show.